Let me open that link. Anyway, I don't know.
CRM, should I share in the chat box?
Sorry?
Can I share in the chat
no,
box?
I already.
Okay, you have got it.
Yeah, you can share. I mean, it is in there. It is in there. This thing only.
WhatsApp.
Yeah, this is the one. Yeah, it is there in the WhatsApp one. So, anyway, so this is the link. So, okay. So you are familiar with D flip-flops, right? So a shift register is just a chain of. It's just a chain of flip-flops. Maybe. So for double double, the data moves from left to right. So I am drawing it accordingly. So you can draw as many. So these are all D flip-flops. You have only studied D flip-flops so far. So let us just restrict ourselves. We'll be looking at other flip-flops later. But for now, let us just restrict ourselves to D flip-flop. So this is how what happened. Yeah. So your data comes in here and so this and here you have a clock. All of these have a clock input. And these clocks are tied up together. So this is your clock. So this is just a serial shift register. Alright. This is simply a serial shift register. Alright. So is this okay? I mean, this is a serial shift register. Any questions regarding the serial shift register? Yeah? Hello?
So what is the function of this register?
Oh, function is very simple. You can shift data in. So if you look at the behavior, So what is the initial state? Say T0. T0 is, you do not know the values of these things, right? You do not know the values of these things. And let us say at the input you have x0. So at time 1, you do not know the values of this, but sorry, this is x0. So the value of this is x0, and you have, this is the input. Let us say that this is the input, and this is the flip-flop states. You can say states. Alright, so and say this is x1. So at time 2 the value will be, so this will be x0, this will be x1. Alright, and let us say over here you have input x2. So if you call this, say, if you call this D0, D1, D2, and say Dn. Alright. So at time n plus 1, you'll have x0, and here you'll have xn plus 1, xn minus 1, so on. So that is how the shift register works. So are you okay about the functionality of the shift register? Any questions? Yeah? Any questions?
No, sir.
Okay, so shift register is a very simple thing. Now let us look at, so you know that for your double, sometimes you got to add a correction, right? You got to add a correction. So for that you need the parallel load facility. So let us again draw a simple shift register with let us say just 4 registers now. So you have got 4 D flip-flops, okay? Let's draw that. So this is, let us say D0, this is D1, D2. Now you also want parallel load facility. So if you want parallel load facility, you can have a multiplexer here, 2-to-1 multiplexer. And this one is the parallel input. So everywhere you have a multiplexer. So now you have, let us say y0, y1, y2, y3, and here you have the input x. And as usual, you have the clock. So we are talking about a synchronous design. All right. So you have the clock here. All right. This is your clock, and here again you have. So let us just have another color. So this is, serial parallel. So this one controls whether you will do serial loading. So let us say this is 0, this is 1. So you already know how to use the multiplexer. You have already designed this module before. Alright. So this one is if it is 0, then it is serial load, or you can also say for this it is, for this particular thing it is left shift. And 1 is parallel load. Alright. So that is what it is really. There isn't much to it. That's it. So are you okay with, so here also if you look at the diagram, that's exactly what they have done. They have just given you the diagram of the I mean, they've just expanded the multiplexer. Now over here, over here, let me just circle this part. So sometimes, if y0 is equal to x0 is x, if this situation happens, then you don't need the multiplexer. No marks, so you can say no need all right, if this situation happens. All right, so that is what you see over here. There is no multiplexer at the leftmost and at the input. So it depends. So if y0 is always equal to x, then you don't need this multiplexer. But if these are different, then you need this multiplexer. All right. So this is parallel shift. So this is what you call a piezo. Parallel. So this is. Of course, I mean, this one can also shift serially. So parallel in, serial out. But it is just or you can call it shift register, more shift register with parallel load facility. This is probably better. This is probably better. It's just a shift register with parallel load facility. That's all. So that's it. So do you have any other questions?
Sir, can you please demonstrate the working of the D flip-flop in the software that we are using?
Yeah, so I think what you can do is, you have been given the circuit of the D flip-flop, right? You have been given the circuit of the D flip-flop in your...
Yes, sir.
So that's simply a network of gates. So what you do is, you just make a module for the D flip-flop, DFF, let us say, and you test out. Say you follow the usual procedure. First, wire up that circuit for a single D flip-flop. Test that it works. That means with every whatever input you give, once you apply the clock, that input should appear at the output. So once you have tested an individual thing, you wire up exactly this circuit, or to start with you can wire up the earlier circuit, which is simpler. So just see that whatever data you're given, it just shifts it in. So once you know that it is shifting it in, you are in a position to do your design. So yeah, you should. So the first step, I think that is what is written in the assignment statement also. The first step is to wire up your D flip-flop according to the diagram given in the circuit. So note that you should, you have the facility to, okay. So for a D flip-flop, whatever data you shift in, that will override whatever unknown value you might have inside. So if you look at the output, initially it will be unknown X, and as you start shifting, those X's should be replaced by whatever data you are shifting in. All right. So that is what you need to do.
So, sir, you are suggesting that we make our own D flip-flop and not use the D flip-flop given there?
No. In fact, don't use that, because that might be a bit problematic. I mean, you can always test that. It's always a good practice to test that. But in fact, I had this tool is also being used by another college where one of our retired faculty members has gone. So there we did an experiment with the shift register, and we faced some problems with the flip-flop that was there. So you can always test out the flip-flop that is there. Actually, that also was used before, but anyway, we had some problems. So I just wired up flip-flop according to the usual standard circuit, and then there was no problem with that. So I would recommend you to. In fact, that is the first part of your experiment, to wire up a D flip-flop. So just wire up a D flip-flop, then you create the shift register with parallel load facility. So what is there in the assignment? Let us just see. So first is, so first is you wire up a D flip-flop, then you make this shift register with parallel load facility, and then you just got to make your binary to BCD converter. Okay, so that is based on just the same algorithm. Only thing is that you got to you got to implement that algorithm in this. So you did a parallel implementation before. So now you can do a serial implementation. All right. So it's actually a simple experiment, really. So any more questions?
So in the parallel one, we we were giving all the input at once. How are we
Yes,
giving the input here?
it will be serial. In fact, if you remember the example that we did in the class, there we handled the input serially. Do you remember the examples? There, that is how actually the original example that we did, the examples that we did in the class, there the input was serial. We are shifting in from right to left, right? If you remember the example. So you will be actually mimicking that same example, the same example which was worked out in the class, you will be mimicking that directly. When you did the parallel implementation, you had to actually, do a parallel version of that example. But now you will be mimicking that example in toto. All right. Is that okay?
Yes.
All right. So I think you can, this is a very simple experiment, so you can just try to do that. Okay then, if you don't have any more questions, then I'll close the session. Do you have any more questions?